Alright, rolling with the fury and the drive, I guess the sleep deprivation, that sudden burst of energy that comes to you from the previous video. I thought might as well just make the second one while we're at it. I'm going to be very blunt in saying that I'm going to cheat on this video yet again. If you want to design this properly, you should design it from scratch. Make sure that you are actually getting all of the right features. But I want to make this quick so everybody can just follow along. So I'm just going to copy this. This is the shape that we use to make the actual taper sleeve. Yep, that beautiful thing. I'm just going to paste it. Now we have it. Okay. I'm going to hide it. Nobody needs to see that. Go away. Oh, no. Hide that one. Cool. So, I actually want to build the coupler now, the piece that actually attaches to the brace. This is real simple, but it's also real easy to mess up, as I found out the hard way. So, nothing really fancy. It starts off with a box, a 40 by 40. Actually, 40 by 40 by... Actually, yeah, it's a 40 by 40 by 40 box. So, 40, tab, 40, ta-da! Okay. We're gonna not have copied that square. It's still in the clipboard, but I have to do this properly, I guess. Okay, 40, tab, 40, enter E for extrude. Gonna make it 40. Getting real fancy. We're gonna draw... I clicked line. That's not what I wanted to click. Control V. Okay, now I would like to set the pivot point to be here. That's not at all what I wanted to do. So, we're going to pretend I didn't do that. Scroll. I'm going to set a point in the very center of this cube, the wonderful magical cube. You'll notice how, for some reason, it's being a pain in the butt. That should be center, if my eyes don't deceive me. I'm going to paste that shape from before. I would like to group all of these together. Evidently, that's not going to happen. Yeah, see, I don't know why, but it's only selecting the center point. So, let's try to... that's probably what I did wrong the first time. Okay, here we go. Let's get that back to the actual orientation it's supposed to be. I think... No. Could I have done this the correct way? Yes, it snapped the corner to the origin. I could have gone over 20 and over 20. You know what? As a matter of fact, I will go back and do that. Let's do this the right way. If I'm not going to do it properly, who is? We're going to move that. And X and Y, doesn't matter. We're going to go 20 and X. We're going to go 20 and Y. We're going to go negative 20 and X. We're going to go negative 40 and X. We're going to go negative 40 and X. Okay. Yeah, that does make sense. Axes are weird here. And bada bing, bada boom. We have it in the correct orientation. Now, one of the things that we talked about before. Single point coming towards an edge. One thin section. Which means all the force is going to be directed right down here. So, if we rotate this just a little bit. I really don't want you to be the point of rotation. I really would like it to be you. There we go. You're just not going to work, are you? Cool. That actually is doing it the right way. I think I want 11 degrees. You could do the math here. I don't care enough to. I'm just going to keep fudge numbers until they look even. Nope. That's not it. 14. Is it really 15? Oh, that's going to be super. Yeah, it's totally 15. Well, don't I feel dumb. Here we are. I'm sorry. Okay, now we're going to extrude this entire thing. Make sure we get them all. Cut. Nope, get back there. Cut this out. I want to leave anywhere from 2.5 to 3 millimeters down at the base here. Remember, this is 40 thick, so I'm probably going to choose 37 just to be safe. That number is just so we make sure we have enough support at the bottom that if somebody really swings a golf club, the coupler is not just going to jam its way right through this. This is the coupler. The tapered sleeve, or handle attachment if you will, isn't just going to slide right through the bottom and break everything. Okay, so there we go. Now we have a cutout that is 37 deep. We're going to make a circle on this bottom surface. So this needs to be whatever the diameter you're going to encounter on the golf club. I'm going to make this 15 just for the point of this video. You need to actually measure this. It's actually a pretty crucial part. Okay, again, this should be the largest diameter that you're going to encounter no matter where you fix this on the golf club. So I'm just going to cut that out. Cool, now you can see. Now for the next part, the fun part. I want to know, and with the current convention, this device is slid on from just above the head of the head, face, I don't golf, I don't know. Yeah, club head, head of the club. So I want to be concerned about the thinnest diameter of the club's handle or shaft, because that's really what's going to be easiest to cut out here, to slide the coupler on. If you make it, for instance, 15 millimeters, you're going to have a lot of free space here where that tapered sleeve can rattle around, it would experience uneven forces, blah, 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 blah. So I want to make this just larger than the thinnest part of the club shaft so that it just has a little bit more room to work with. It looks as though I'm not perfectly centered, but I'm not super concerned about that. Make this into a construction line. Okay, now for Gary's clubs, down towards the base, we're dealing with, I'd like to open this up and actually give you a measurement. I don't think it's any more than 13 millimeters. I think it's actually a lot closer to 9, like 9.6. I'm just going to choose 10. That's also what I have on the original design. I just feel a little bit safer going with that. So we'll go over 5.0. Again, these are really just to set references. They don't have to be used. I'm just kind of being lazy about it. So it's 10. Tab. Doesn't matter. I just want to make sure I can cut this out properly. E for extrude. And we're going to make it two-sided because I don't think I drew this on the right plane. Now let's make it symmetrical. Okay, cool. And now we have the cutout where you can actually insert the golf club. Again, so this is a lot. No, not really, but you know, this, I'm talking the distance from here to wherever this line is. Not a lot, but it might just be enough to help keep the golf club in should something ever happen. Not a guarantee that it will, but, you know, it'd be nice to think that maybe it would. So, I'm going to fillet these edges just so the club slides in really easily. What does it have to be? Doesn't really matter. Am I going to choose 8? Yep, 8 looks pretty good to me. Actually, I'm going to go a little bit more. You can see that right here is part of one of the triangles. I want to try and get it right to the... Well, that's kind of an optical illusion. Let me see if I can pan a little bit better. I want to try and get it right to this edge. I don't know if that's going to be 9. Not 89. We'll leave it at 8. Doesn't really matter in the long run. 8. Ta-da! Okay. And now it's really easy for the club to slide in and out. The next thing I'm going to fillet are these edges. Purely aesthetic. No real reason to do it. I just like a lot of rounded corners. Okay, we're going to make it 5. Let's do 5 all the way around. I got rid of the fillet tool. Darn me. See through the wall. Come on, do it. You know you can. Bada bing, bada boom. Okay, and now we have a nice and rounded coupler. So, let's do the fun part now. Now we have to decide how deep we actually want to set the screws, as well as the holes for this particular brace. I don't know that there's a great answer, to be frank with you. Last time, basically what I did is I drew a line from here to here at, come on, 90 degrees. Okay, it's roughly 6.5. So I like kind of using the center thickness between these two. The bigger point of concern is right here is where a lot of force is going to be transferred. But if the cutout I make only goes to about here, then we still have a very good amount of material to dissipate the force in this general region. So what I would like to do is draw, again, probably a better way to do this. I don't know of a great one. That's 6 point, we'll call it 6.5, 3.25, okay. And I'm going to make a line that extends off the side of the rectangle. I'm going to stop the sketch, and now you'll kind of see why I did this. Notice that point? That's not my reference. So I use this, and again, there's got to be a better way to do this. I just don't know what it is. So, and now see how it snaps nicely to this point? I come down as far as I want. So overall this is 40. I think I like to set it at about 13, 10, 12, doesn't matter. No, I'll choose 13. I didn't need the second line, go away. Also didn't need this line, I don't know what that's coming from. And we're going to build another one that's, wow, 26 minus 40. I actually had to think about that for a minute. Command, stop. Build this as a construction, because I don't actually need this. I'm concerned mainly about this. Now it's actually time to dimension the rectangular cutouts where the nuts are going to seat in the back here. So, again, they're about, I think, 2. Let me get an actual number here. I used 2.65, so I'm going to roll with that again. So 2.65 divided by 2. Why am I doing math like that? Well, it's 12 o'clock at night, and I've done some pretty dumb math before. So just know you can do some basic addition, subtraction, multiplication in the dimension spots, and Fusion actually understands that, which is good, because it's been a rough night. And how wide? approximately 5.7. I'm going to make that just a little bit bigger to 5.8, just so they make sure. Yeah, just so they make sure. Just to make sure that it seats a little bit better. So I'm going to do... Notice how it's snapping to the line? I really don't want it to do that, so I'm going to make this 90, and then tab 5.8 divided by 2. Actually, I could have done that math in my head, but you know what? I didn't care enough to. Now I'm going to make a rectangle. It's going to be tab 5.8, tab 2.6 that I decided on? 2.65 question mark? Also, Control-Z is your friend, folks. Yeah, 2.65. Okay. Okay, 2.65. Tab 5.8. Enter. Now I'm going to mirror this. Again, there's a lot better ways to do this. I'm kind of being lazy about how I actually do this. Makes this a construction line because I don't actually care about it. Mirror. Just this over our mirror line. Select our mirror line first. This wants to be a pain tonight. 1, 2, 3, 4. Perfect. And bada bing, bada boom. Okay, get rid of that because I don't need it. I don't need it. That little line there, I no longer need. Okay, and here we go. Here we have our spacing for the holes, or the cutouts. You can set it however deep you want. Does it really matter? Nope, not the slightest. I chose 16 last time, because again, if we're assuming the nuts are 2.5 in diameter, a flat edge contacting here, a flat edge contacting here, and a flat edge contacting here puts our center just a little past 14. Again, assuming that these were perfectly dimensioned and everything came out perfectly to spec, you know, we'd be at 13.5 rather, but I don't ever assume that. So, make it 16. Perfect. Now, I'm not going to do it on the other side, since you've seen how to do it once. Here is the hard part. There is no easy way to do this. I'm going to draw on the back face. I'm going to go over 14.925. The reason it's 14.925, and you can kind of see some of the phantom dimensions that I'm catching on to here, is when we look at the... Can we stop, please? When we look at where I've actually drawn it from, it is in line with this feature, but it does not actually coincide with the farthest one that we drew. Since we drew on a curved face, this sticks out further than back here. So 14.925 is actually a pretty believable number. We made them so that they were 5.8. Yep. And we're going to go back. Okay, turn all of these, shift, into construction lines. Again, strictly a reference. And now we need to find a few things. So we need to go... We made them 2.65. Right? That's to say that it is 2.65 in diameter. I think. Sleep is now evading me. So technically speaking, I should go 2.65 divided by 2, and that is the actual center location for the holes. But that's not correct at all. It's supposed to be 5.80. That's why that didn't seem right. Let's find our center point. See how that little triangle? That means center point. So it's supposed to be 5.8 divided by 2. But I want to leave a little bit of a fudge factor because that's never actually the case. So plus 0.2. Beep. Awesome. Now you have your line. Now we're going to draw a circle. Again, never assume that is perfect. Fudge factor 2, 3.2. Now this gives a 3.2 millimeter through hole to screw through the brace being kind of back here if you can imagine it, and then the screw going this way into the nut that seats inside here. So we're going to extrude this circle, being very careful not to go too far, so look through. You want to just cut through this wall but not go too far into the back. And there you go. So I didn't show you the whole process because it's pretty, shouldn't say easy, it's not really hard from here. Make the same cutouts on this side, put 2 other screw holes, or well, 3 other screw holes here, or if you really want it, you could even use the pattern tool. Doesn't matter one way or another, whatever you think is most efficient. And that is the basics for the redesign. From here on out, you can kind of delete any sketch lines that you don't actually want or need. You could just hide them over here. That works too. And that would be your finalized model. So again, if you have any questions, feel free to reach out to us. We are RIT Bioprint, capital B, capital P. That is one word. You can find us on Facebook, on our website. We also have an Instagram, we have a LinkedIn, or you can just Google RIT Bioprint. Shoot us an email at ritbioprint.edu if you have any questions, and actually if you have any suggestions too. So, thanks for watching, and sorry to make this so much more, or rather so much longer than it really needed to be.